Alright, hi everyone, welcome back. In today's lesson, we're going to look at prime factorization and how to write a number as products of prime, which is pretty important. Okay, so pay attention. This could be hard. First of all, let's first understand how do we find factors of a number. Okay, say if I want to find factors. What are factors of the number 14? Right? Then the first thing you do is you ask yourself, okay, what are all the possible pairs of number that multiply together would give me 14? And so you can start out with, the basic one, like, 1 times 14, that gives you 14. Okay, 2 times 7 will also give you 14. Alright? Can you think of any other pairs such that when you multiply them together would also give you 14? Almost. So, and by the way, I don't know if you got that right or not, but anyways, it's -2, see, times -7, that also gives you 14, see? And then the last pair is -1 times -14, that also gives you 14. So all these pairs multiply, when you multiply them together, you get 14. So what are all factors of 14? Well, there are 8 of them. They are 1 and -1, and then we put them together as plus or minus 1. Okay, plus or minus 2, plus 2, minus 2, plus or minus 7, and then plus or minus 14. See, so 2, 4, 6, 8. There are 8 of them. Okay, good. So that's how you find factors of a number. So if I ask you to find factors of a number, here's what I want you to do. I want you to list it out. What are all factors of 14? Keep this in mind. Every number can be written as a product of prime numbers. So before we go further, let me give you the definition of prime numbers, and then we'll take a look at a few examples of prime numbers. Prime numbers is basically an integer that's greater than 1, whose integral factors are 1 and itself. In other words, prime numbers are numbers that are divisible by itself and 1, but it has to be bigger than 1. So 1 is not a prime number, okay? So the smallest prime number happens to be, 2. Okay, other prime numbers, 3, 5, is 7 a prime number? Yes, 7. Okay, 9 is not a prime number because 9 is divisible by 3. So 11, okay, 13, 17, 19. What about 21? Good, 21 is a prime number. Okay, and 23, okay, and so on and so forth. So there are an infinite number of prime numbers. Okay, now the next thing we're gonna look at is recall what I said. Like every number can be written as a product of prime number. So say if I want to write the number 14 as a product of prime number, I can write the number 14 as 14 is equal to 2 times 7. You see? So 2 is a prime number, 7 is a prime number. So I wrote 14 as a product of prime numbers. Alright, and it turns out that you can do that for every number. So let's take a look at how we do that. Okay. So we call that prime factorization. So find the prime factorization of 48. Okay. In other words, when you see the two words prime factorization, keep in mind that they want you to break down the number 48 and write it as a product of prime numbers. Alright? Be careful. So what we're gonna do is, I'm sure most of you remember the factor tree. So we're gonna go ahead and take the number 48 and we're gonna break it down. So ask yourself, what two numbers multiplied together gives you 48? Well, that is 2 and 24. Okay, 24 is 2 and 12. 12, 2 and 6, 6, 2 and 3. And that's the best you can do, and you can't really break it down any further. So guess what? 48. Okay, as a product of prime number, it's it's 2 to the 1, 2, 3, 4. There are 4 2's, so we write it as 2 to the 4th times 3, and we're done. Okay. Now let's take a look at another one. So say if I want to find the prime factorization of not 48, but say 220. 220. Okay, so I do the same thing. I go, okay, 220, break it down. That's 2 times 110. Okay, this would be 2 times 55. 55, 2 times 11. All of them are prime number, therefore I can't break it down any further. So my process, you stop your process and you rewrite the number 220 as there are 3 2's. Oh, I'm sorry, this should have been 5 times 11. Okay, so there are 2 2's, so we go, oh, that's 2 to the 2nd power times 5 times 11, and you're done. Make sure you distinguish between factors and prime factorization. Very important. And some of you will be confused between the two. If you do, rewind the video and check out the first part where I explain the factors. Alright. Now, finding prime factorization is pretty important because that's going to lead us into the greatest common factor. Okay, so let me first give you the definition of the greatest common factor, and then we're going to go ahead and we're going to find it. The greatest common factor, shortened by the 3 letters GCF, okay, of 2 or more integers is defined to be the greatest integers that is a factor of each. So let me give you an example. Say if I want to find, okay, so find the GCF. And by the way, if you need to pause the video to copy down the definition, or just to have more time to comprehend the definition of the GCF, then you're more than welcome to do so. But I'll explain to you again. I'll explain it again. The greatest common factor is the largest number that you could factor out from both of these numbers. If you look carefully, these two numbers has 2 as a factor, it has 4 as a factor, it has 6 as a factor, and it also has 12 as a factor. So, and it also has 24 as a factor. Right? So out of all those numbers that I listed, 24 is the largest one. Okay, so when I look for the GCF, I'm trying to get that answer, which is the number 24. Alright? Now let me show you, okay, so we know the answer is 24. Let me show you the technique on how we find that number. The first thing we do is we take the number 24 and 48 and we prime factor each number. So 24, okay, if you prime factor 24, you get 24 is 2 times 12, 12 is 2 times 6. So the prime factor 24 is going to be 2 times 2 to the 3rd times 3. If you prime factor 24. Okay? If I prime factor 48, okay, and I'm going to just kind of cheat here so that I can save time, I get 2 to the 4th times 3. Okay, so you can do it and you see that